These are the averages we used in order to predict how far a half-inch gumball would go using the averages of flight time and distance with the 1-inch gumball. These values are listed here. Since this is a projectile motion question, we split the vertical and horizontal axes and evaluated them differently. Here we used the velocity in the x-axis because we know there's no acceleration there, so the acceleration goes to 0 and we can ignore that. And then we're left with displacement over time, which gives us a velocity of 3.1 feet per second. Then we used the Pythagorean theorem in order to find the V0 of the total system. In part B, we assume that the kinetic energy is going to be the same since we're using the same catapults, and by simplifying the equation, we get 28.65 feet per second. We then put that answer into a projectile motion equation that gives us the time of the flight. After that, we use the Pythagorean theorem to find the vector component in the x-axis for the velocity. So then we get 10.37 feet as the expected distance for the half-inch gumball. This is further than what we ended up getting on the competition day, but that makes sense because these calculations are ignoring things like air resistance.